So hi and welcome everybody. Welcome back to the second part of the lecture. In this part, we will continue talking from where we left off. And in the previous lecture, we talked, as you know, about security of computer networks, what things you need to provide and things you need to provide. Basically defined confidentiality, authenticity, integrity, availability, privacy, and defined each one of them. And we gave examples on attacks and how to protect against. Now we need to define data communication. What's data communication? So basically data communication is the exchange of data between two nodes via some form of link such as cable. So this is when you hear the word data communication in computer network box, this is what it means. Data communication, there are two nodes or more than two nodes sharing information or sending or communicating with each other via cables. These cables can be wired, the medium basically can be wired or wireless. The data flow, what's the meaning of data flow? Data flow means that the data is going to flow from one node to another. And we have 4 or 3 types of data flow. Yes, we have simplex, half duplex, and full duplex, and in-band full duplex. So this is very important to pay attention to and distinguish between them and give me example on each one of them. So what's simplex? If we want to define simplex, simplex means the communication is always unidirectional, one way. You can either send or receive. Give me example of this, like one device can transmit and the other will only receive. Give me example of this. The mouse, the TV broadcasting channel, the FM, AM, TV, mouse, printer, keyboard, those are one-way communication. Just you can send information, you don't receive. Have you ever uploaded information to your TV broadcast station? Yes? No. You just receive your channel in the downlink, but you don't upload anything. This is TV, unidirectional. This type of communication, we call it simplex. Example of it, radio broadcasting, television broadcasting, computer to printer communication, and keyboard to computer connection. The second type is half duplex. What's half duplex? Communication is in both directions, but not at the same time. You either send or receive. At a certain time, you either send data or receive data. Give me example on this. Exactly, the radios with the police and security guards. Walkie-talkie, two-way radios. The push to talk, push to listen, something like this. Those are with the police and security guards. Full duplex, what's full duplex? Full duplex means communication is in both directions, uplink and downlink, transmission and reception, but at the same time, you don't feel any discontinuity. Example of this, your mobile phone, your PC talking over the internet, mobile phone talking over the wireless network. This is full duplex. So communication is in both directions and it goes simultaneously. Example, mobile phone, PC, servers, and so on. This small picture summarizes briefly the differences between them. And I will bring a question about this maybe in the test or the quiz, because this defining the differences between them is very important. Now, I will add another category called in-band full duplex. This one here, in-band full duplex. What's in-band full duplex? In-band full duplex means that the two devices can send information, receive simultaneously at the same time, and also within the same band. This is the difference, within the same band. Because normal full duplex, you use different frequencies for uplink and downlink. But in band full duplex, you basically, within the same band, you are transmitting and receiving. And therefore, this technology can double your data rate and double the capacity of your network and the throughput at the end device. Now, speaking of this, now we can talk about protocols in computer network. When you hear the word protocol, what's protocol? All communication schemes will have the following things in common. A protocol defines something from the source to the destination that can work in a certain principle according to certain algorithm. So for a communication network, a link to consider, we have a link, we have three main things. We should have source or sender or a transmitter. All these three words are equivalent to the same thing. Transmitter, sender, or source, they are the same. You have destination or sink or receiver or sendee, E-double-E. Also, it means the receiver. And you have channel or medium. The channel or medium can be wireless or wired, and there are different types of wireless channel, different types of wire. So protocol, what's the meaning of protocol? Protocol is a set of rules that govern data communication. Why do we need protocols? To regulate, organize, order the communication between nodes so that we avoid interference, we avoid misconfiguration, we avoid misunderstanding, and make sure everything goes seamlessly and without any problems. Imagine all of you trying to access the access point at the same time. What will happen? The access point will crash, will not be able to handle all of you. So how do you manage this? You let the user access the network in a random manner. You give them time window so that you send a signal and you sense if the channel is busy, I back up, I don't send. I listen again, is it free? If it's free, idle, then I send. Something like this to avoid congestion and interference and make sure the network is always available to users. So protocols in communication network, a protocol used in network communication also define the following. What are the things that protocol defines in communication network? First, message encoding. What type of encoding are you use? The protocol is responsible for defining this. And once the protocol defines this, it defines it for the transmitter and the receiver so that they understand each other. Because if someone is using a protocol which is different from the other node, then they will not be able to understand each other and they will end up losing the communication. So first message encoding, then message formatting and encapsulation. For example, you have the packet. The packet is generated at the application layer, like your data start being generated at the application layer on a form of video or voice or text or image, whatever, based on the application you use. And this goes down to the lower layers: application, presentation, session, transport, network, data link, and then physical. So what each layer adds to this information? For example, the network, the transport layer will add a port number to the data. The network layer will add an IP number. The MAC layer will add a MAC number. The physical layer will add some other details related to modulation and coding, channel coding, source coding, mapping tables, I50 size. All these details should be the same at both nodes, at both sides. Message size, what should be the message size based on the application? Message delivery option, and so on. We can say that these are the elements of the protocol. Let's start with message coding. Message encoding, it includes two types of encoding. You have your message source and you encode it. Like not even two types, we have many types of encoding, but in this lecture we will explain three types. The first encoding is source encoding, the second one channel encoding, and the third one is signal encoding. So source coding or source encoding, what's the meaning of source coding? Your app generated certain amount of data, let's say 1 gigabit of data. But this data, lots of this data is random, is redundant, and you can compress this data to a lower size. Why do you need to compress it? So that you reduce the amount of traffic over the communication link, and the saved amount of traffic or bandwidth would be used by other users to communicate over. So in this case, this is the purpose of source coding. Source coding compressing your signal. Source coding has different types. It can be lossless compression, it can be lossy compression. Lossless compression means the quality doesn't change. Lossy compression, it means that you give up on the quality on the benefit of gaining more on the compression. What's channel coding? Channel coding is adding some redundant bits to your data packet so that you can protect it against the impairments of the channel when you transmit it. This is channel encoding. And the third type is signal encoding. What's signal encoding? Let's say you generated your data is now zeros and ones. Yes, when it's on the computer, when your data you generate it in the computer, it's an application, image, video, whatever, and at the end you convert it to zeros and ones, so that it can enter to your microprocessor, and the processor will manipulate it, encode it, process it, work on it. But after that, you want to transmit it over a medium. The medium cannot understand 0 and 1. If it remains 0 and 1, you will not be able to send it to the medium. So to be able to send it and make sure that this signal can propagate over the cable or over the air, you need to convert it to an electrical signal. If it is a cable, you can, up until to the port, to the microcontroller port of your PC or mobile phone, you need to convert it to electrical signal. How do you convert it to electrical signal? You make a rule like this. If one comes, I have a sequence of data, zeros and ones. If 0 comes, generate a signal of value equal to minus 10 volt. If 1 comes, generate a signal of value equal to 10 volt. Plus 10 volt, minus 10 volt. So, and there are different ways of doing this and encoding it. So the signal 0101 now, it's like this. It's sequence of pulses. Now, okay, now I want to transmit them over the medium. This is electrical signal. I need to convert it now to what? Electromagnetic signal. How do you convert it to electromagnetic signal? Via antenna. From physics, if an electrical field passes through an antenna and this electrical field is in movement, it has a direction, it's moving, it generates charges around it, and these charges generate electromagnetic field. This electromagnetic field is what we call the coverage area around the access point. If anybody is receiving this electromagnetic field, any tiny amount of it, he's capable of receiving the data, because the data is encoded and carried within this magnetic field. If it is a cable, then the transmission line is also an electromagnetic field. When the electricity passes through a cable, it generates electromagnetic field, yes? You can even get the data around. Sometimes they say that if your communication is guided, what I mean by guided, it's within a cable. Can you steal the data being transmitted in the cable? Yes, you can steal it. How? Bring another cable next, or antenna next to the cable carrying the data. Since the current is passing in one way, it generates electromagnetic field around it, and you can generate some induction in your antenna or cable and get the data out of that. So if your data is passing through a cable, doesn't mean that it's secure. I can decode the data carried by that cable if I'm close enough to it. It depends on the speed or on the amount of current and how strong it is, and many factors. So these are the 3 types of coding that I want you to be aware of, but there are also different types. And second thing that the protocol is responsible for is message formatting and encapsulation. Message formatting, both should agree on certain format. ASCII code, I'm using ASCII code, please stick with ASCII code in order to be able to map, because what the receiver receives at the end of the day signal, he converted to bits, zeros and ones, and then he needs to convert these bits to letters, to images, to videos, to speeches, to audio, to anything. If they are not agreed on the format, they will not be able to communicate. Although the communication might be successful over the medium, you equalized correctly, there is no impairments, nothing. So the second thing beside the agreed format is encapsulate the information to identify the sender and the receiver rightly. Encapsulate the information. I told you there is some side information attached to the data. Like the packet has raw data, and has also side information data, which include the IP, the MAC address, the port number, the sequence number, the order, all of these. Because when you send your message through the network, your message gets cut or chunked into small parts, small chunks. And each chunk of these pieces has unique sequence number. Why we need this unique sequence number? Because these chunks travel over different paths, and by the time they reach the receiver, they reach random. So the receiver responsibility and job is to reorder these chunks in a sequential manner so that the whole packet can have a meaning now. So this is the encapsulation. Message size, of course, message size. Message size is also, and the data packet length, where humans break long messages into smaller parts or sentences. Long messages must also be broken into smaller pieces to travel across a network. We also have the message timing, flow control, and response timeout, and the message delivery options. For the message delivery options, we have three types. We have the unicast, the multicast, the broadcast. The unicast is one sender and one receiver. One sender and one receiver talk with each other. The multicast means one sender sending the same data to few receivers, couple of receivers. The broadcast means that sender sends the data to all the participants in the network. So let me give this example. You have access point and there are 10 users. If this access point is talking to one user only, this we call it unicast, one. If it is talking to 5 among those 10, we call it multicast. If it is talking to all the users within the range, which are 10, then this is called broadcast, all the users. Beside this, we have also peer-to-peer network. What's the difference between peer-to-peer network and client-server network? One key difference is that this one is not centralized. We call it distributed network. And this one, client-server network, we call it centralized network. Centralized network. Another example, can you give me another example on peer-to-peer network? So Hamza, another example on peer-to-peer network. Blockchain maybe? Blockchain is an example of peer-to-peer network. So in peer-to-peer network, no centralized administration, all peers are equal, simple sharing application, and not scalable. A client-server network, centralized administration, it has a request-response model, it's scalable, and in this case, server may be overloaded. Yes, because server has certain RAM, certain processing capabilities, certain resources. If these resources run out, then it will be difficult for any additional user to access the server and get service from it. So any computer network has three components. We briefly discussed this: nodes, media, services. Nodes, when I say nodes, I mean computers, network printers, PCs, mobile phones, mobile handheld devices, and so on. Intermediary nodes, switches, routers, wireless access points, security devices like firewalls, bridges, and so on. The second, this is the first point is node. The second is media link. Media, it can be wired or wireless. For wireless, we can have infrared communication, radio communication, microwave, and satellite. For wired, we can have Ethernet crossover cable, fiber optic cable, USB cable. Now, speaking of wireless, we have something called Wi-Fi and something called Li-Fi. So what's Li-Fi? What's the meaning of Wi-Fi first? Wi-Fi stands for what? Wi-Fi stands for wireless fidelity. Li-Fi stands for light fidelity. So what's this technology? You can get data connection from light. From the light can provide you illumination, you can see, and also data link communication. Is this technology available?
Yes.
Yes.
Fiber optic.
Not fiber optics. This is fiber optics. Still, you are using fiber. Well, Wi-Fi.
It still doesn't.
True, but you are using cables. You are using fiber. You are using guided medium. Wi-Fi is a technology that provides you data communication from the light. So the light inside. See, let's simplify it more. In your home, in order to get internet access, what do you have? What should you have? Access point. Access point provide you with wireless connection. Now imagine this situation. To connect, somebody comes to you and tell you to connect to the internet, you don't need wireless access point, you need just light. This light, exactly this light. Is this technology available? Available. Which companies are doing it? Many companies, several companies in China and a few companies in UK. Can you buy devices doing this? Yes. Do we have smartphones that communicate with this technology? Yes. Do you want to buy them? Send me an email. It's available. It's a technology that's available. You can get communication from light. This is what we call it visible light communication, Li-Fi. This is Li-Fi, not Wi-Fi, Li-Fi. Search about it if you don't know about it, if it's the first time for you to know about it. Why it's better than wireless? Why it's better? Many reasons. First, you don't need to waste energy and money on having a different access point. You use the light itself to provide you with data connection as well as illumination. Second, your data, your links, your wireless signals cannot go outside of your walls, which means you are protected. Your signal cannot leak outside. Your signal remain confined within your room. But here, if you have an access point, your access point can be received by someone walking around from behind the wall, because wireless can penetrate through walls, but Li-Fi cannot. Now, what are the third point to make a computer network is service. So we have services. What are the services available? We have media storage services, file sharing, instant messaging, online gaming, VoIP, voice over IP, video telephony, browsing the internet, World Wide Web, file sharing. All these are examples of services. Why services are important? Because they make the internet useful. You remember when was the internet invented? The internet, the first trial of, link space, something, the first internet company was, the purpose of creating the internet, what was it? The purpose of creating the internet was to share files between 3 universities in USA. That's the purpose of the internet, around between 60s and 70s. So that was the main goal of building a network, to share files. After that, things have changed, improved, and we have so many services now. So when the internet was invented, it was just file sharing, sending and receiving. But now we have so many services. Yes. Question.
Maybe it's out of situation, but how was the deep web formed? It was like a basic stuff that they were doing first with the internet. Like how was it deep web?
Okay. He's asking about something related to deep web. I think what I'm talking about now is not related to deep web, but let's clarify the word deep web and dark web. Many of you have heard of the word deep web, dark web. Anybody? So what's the difference between this web and the web we are using? So the web we are using, let's assume the internet is something like this, the amount of the data. We are using this. Let's assume the internet is a mountain. We are just using the ice break of the mountain. The internet, when you access over Google, you are just seeing 10% of the available internet. Google just allows you to discover just 10%. Where is the 90%? Hidden. Who can access it? Not regular people, not you and me. How to access it? Question mark, out of the scope of this course. For a different course. For a different course, there are special browsers, they don't have totally different than, and they don't teach these in the schools. They don't teach. We give just one lecture about it in the wireless security course for master students. But this is out of the scope of this course. Deep web, dark web is out of the scope of this course. But it's good to know that there is something called this. How, question mark, needs another course to teach you all these things. So now the classification of computer networks. We have three types of computer networks. We have LAN, MAN, WAN. LAN, MAN, WAN. The difference between them. Local area network, metropolitan area network, wide area network. Give me examples. Local area network, like a network you set up inside your lab, inside your home, inside this class. Local. What's the local? What's the key property of local area network? If I can share information with anybody in this room, and whatever you send over the link, it can be received by all of us. This is local area network. You don't need a router to build it. What do you need? You need to just take the cables of all the PCs and link it with a hub or a switch. That's it. This is local area network. It can work without the internet. You can send information, share files with your friends without being connected to the internet, because you are connected with local area connectivity principle. Metropolitan area network is a bigger network. So here let's just read this about local area network. Is a computer network that interconnects computers within a limited area, such as residence place, school, campus, building, and you can use wired or wireless. I told you can build this independent of the internet, and you can share and send and receive. And we will teach you how to build this, but now we are giving just an overview. And here, metropolitan area network is a computer network that interconnects user with computer resources in a geographic region of the size of a metropolitan area city. Like if the network is so big like a city, this we call it MAN, metropolitan area network. You have different local area networks interconnected with each other. Local area network is one network within a class, within a lab, within a small residence area. But if we have thousands of these local area network interconnected with each other, we call it now MAN, metropolitan area network. Wide area network is a telecommunication network that extends over a large geographical area for the primary purpose of computer networking. This you can call it the internet here. Wide area network. In devices, it requires both switches, routers, bridges, all these devices. So these are the basic principles, the basic ones: WAN, MAN, LAN, and we have what? We have wireless access point here as well, but we are not mentioning it. So it's considered under this category. New trends in computer network. Bring your own device. What's this bring your own device trend? And what's online collaboration, cloud computing, blockchain? All of these are different types of networks. Like somehow they are peer-to-peer, not centralized, like a blockchain. Cloud computing is centralized. And bring your own device and online collaboration, it's like just let me use the resources of your computer and I will let you use the resources of my computer. when your computer over the internet, like give you example. What's the most famous service, peer-to-peer service we have to download files, large files? Do you remember that service? I forgot the name. What's the name of the peer-to-peer downloading? In the old days, when we wanted to download a very large file, we used to have a very specific service. Do you remember it?
Like a download manager or something?
No. Peer-to-peer file sharing service applications. Do you remember any of this stuff? Like there is a peer-to-peer, it connects via IPs, and this is used basically, this is one of the, this is kind of peer-to-peer network where you can use it. In order to use it, you need to make your computer part of the whole network, where other users, when you just run the app, other users can use your resources. Torrent, exactly, Torrent, thank you. Torrent is a service that we, anybody, all of you used it, guys, yes? Torrent is a peer-to-peer communication network. When you run the app, you basically let the other user use your resources and you share files and this. To use Torrent, what do you need to do? You need to download it to your PC. It's like a browser. It's not a browser, but think of it like this. To access Torrent, you need this application. To access the internet, you need Chrome, you need Brave, you need this. So Torrent is like this.
Mostly used for pirated applications and stuff.
Exactly. And I don't know why you didn't guess it quickly, but like I forgot it because I'm not using it actually, Torrent. But I remember before 10 years, we used to, if we want to download something really heavy and like large files, we use Torrent. So blockchain also a new emerging trend. Blockchain also, if you want to mine, if you want to make your computer available to the network, you get paid even. Yes, anybody knows this? You can make money by making your making your PC used by others. Yeah, yes, mining and these things.
Mining, like you use your GPU.
Exactly, and also for helping with the transaction and the speeding up. But the speed of your computer will get lower.
There are some applications like new crypto money and stuff.
All of them the same.
And individual PCs can act like nodes, individual nodes for a complete blockchain and stuff.
Yeah, exactly. Those are the new trends. You can rent your memory, you can rent your hard drive, you can rent your microprocessor power. Rent it. The way you rent a home, you can earn money. Like this is a new trend in networking and computer network. We have storage area network, cloud computing. It's the on-demand availability of computer system resources. What's the beautiful thing about cloud computing? Why cloud is important? Why it's really, many companies, many enterprises are so dependent in cloud. When you are accessing a cloud, all your files, all your data, they are available on the internet and you can access them from any device, from anywhere you want. So basically, you don't want to have resources at your end device so that you can access the resources existing in the cloud. This is the beautiful thing about it. And so it saves resources basically. If you have a device that doesn't have powerful processing power, powerful computing power, powerful RAM, powerful CPU, if your data is on the cloud and you run all the programs on the cloud, then there is no problem. Now I want to talk a little bit about mobile phones. When you go to the market and want to buy a mobile phone, what are the things that you look at? If you want to buy a mobile phone, what are the key things that you look at? RAM, ROM, processing speed. But mostly, the most important one, what's it? Beside the camera, I know you like the camera to be very good, but beside the camera, what do you look for? Space, yes? How much is the RAM? How much is the space? The hard drive, the hard disk, yes? If now the companies, they keep producing phones like this so that customers keep longing for new devices and changing their devices and getting and buying new ones. But in fact, In fact, you don't need to have large memory or large hard drive space in order to run all the applications in Chrome. You can have them hosted on a cloud and just access them over the cloud and use the resources of the cloud for this. But they don't want to do this. They want the customer to keep buying phones, and you know, when your memory is full, you want to replace your phone with a better phone with a larger memory, and this kind of pushing you to buy a new phone, a better phone. But in fact, with the cloud, you don't need this. You can basically utilize the resources of the cloud in order to run your applications. I hope we can see a company in the future that does this. You can convert your ring. Imagine your smartphone can be in your finger. The whole smartphone. Imagine in the future, 10 years from now, your smartphone will be something like just one button in your finger. Why? Tell me why. If you shift the RAM resource, if you get very high speed internet connection, like gigabit per second, 6G I'm talking, not 5G, 6G, 7G, 10G, very high speed internet connection for each and every one, and you get large memory resources on the cloud and large hard disk, enough space on the cloud, hard drive, memory and connection. Why do you need to have resources in your PC or in your phone? You don't need. The internet is very fast. I just switch on my phone, a screen pops up in the air, like or in a wall, and then by another click I can access the cloud and run any app I want. All my personal information is hosted there. And in that case, I don't need to keep buying phones and competing with other users about memory and resources and hard drive size. This is my prediction for the smartphones in the future. I think smartphones will be like this. You don't need, you just button. Everything, you saw the screens on the air? Screens on the air. You can convert any surface into screen. There are devices that can convert any surface into screen. If you want to type on this phone using a keyboard, there is a keyboard that can project a virtual keyboard on your service and start typing. You might have seen this product. In the future, the smartphone industry will change. In the old days, we were competing with each other on getting the smallest phone. Yes, the smaller the better. That was the trend. Now, the larger, the better. Why? You need larger screen. Yes? But again, after 10 years, we will return back to the smaller, the better. Because everything will be in the cloud and the speed of the internet is very high, that you can have all your stuff hosted on the internet and access it quickly as if it is stored on your phone. When will we reach this reality? What do you think, Hamza and Ozan? You think 6G will bring this to us? Can we really have this vision fulfilled and achieved by the reach of 6G or 7G? I'm pretty sure within 10 years we will have it. This technology, that everything on the cloud, all your stuff, and you just, even the screen on the air quickly, or in your hand, or anything, or on service, you can project it any way you want. I'm pretty sure there are companies working on this. So this is the trend. Now let's talk about network topology. Network topology is the shape, the geographical of the network. So we have different types of network topology. Network topology means arrangement of nodes of a computer network. Topology means layout. We have physical topology, placement, which means placement of various nodes. We have also logical topology, deals with the data flow in the network. What are the topologies we have? We have the bus topology, the ring topology, the star, the mesh, the hybrid. So in the bus topology, this is the bus topology here. what do you have? All data transmitted over common transmission medium. So the data here in the bus topology is transmitted over common medium, which means that each and every PC will be able to access the data transmitted over this network or this line. Ring topology, this is the ring topology here. A ring topology is a bus topology in a closed loop. So this is open loop, not closed, this is closed. What's the difference? If you cut here, if you make any cut here, the whole network will be down. The whole network will collapse if you have any cut or any break in any of the lines. Star topology, this is a star topology, it's centralized. Every node is connected to a central node. So if this main node goes away, the whole network goes down. Mesh topology is the most resilient and the most powerful network, but it's also the most costly one. In this network, each node can be connected to all the other nodes. So if this link fails, there are other 3 links connected still. This is, we call it the fully connected topology. The mesh topology is really the strongest one, but is it practical to implement? No. Do you know any company? No, it's not. It's theoretical. Why? Because it's costly. Imagine each node you need to connect it to all the nodes. It's really costly. Hybrid topology, as the name implies, it merges or mixes 2 topologies with each other. Like you can use the ring with the tree, the ring with the line, the mesh with the star, and so on. Now here there are more details about the differences, the advantages, the disadvantages between them. We will go over them, but for now we can stop here and see you.